If this spool rests on two small rollers, A and B, and a constant horizontal force of 400 newtons is applied, notice this force is at an angle. Okay? To the end of the cable, compute the angular velocity of the spool when 2 meters of the cable hang on rail. Neglect friction. Notice here I have the internal spool has a radius of 200 millimeters. The external one has a radius of 500 millimeters. And there are these angles here, 30 and 30. So obviously the weight is 250 times 9.81. And we've got this small triangle, 345, which can give us the direction of the 400 newtons. So you can see my free body diagram is this. My force going up here, 400 newtons. Sorry. And A and B. And my weight of the whole spool. Sorry, 250 times 181. Now my kinetic diagram. I've got V and omega, the angular velocity. Okay. Initially, system at rest, so omega 1 is 0. I know the mass is 250, so I can find the weight, 250 times 9.81. Now, T1 plus sum of work from 1 to 2 is equal to T2. Obviously, because omega 1 is 0, notice I only have rotation, so T1 is 0. T2 is half IG omega 2 squared, where IG is actually 250, which is the mass, times 0.35 squared, which is the radius of gyration. Okay? So this would give me T2 to be 15.3 omega 2 squared. So far T1 is 0, T2 I just found it, 15.3 omega T2 squared. Now I need some work. So sum of work done from 1 to 2. What work do I have?
Sorry?
What work do I have in this? Where is the work happening?
Into the center?
Yeah, so it's caused by what? Which forces? I always think like this work, there must be a force involved. So it's either the weight. Notice in the previous question it was weight. And moment. Yeah.
The 400 newtons pulling on?
400 newtons. So how can I find the 400 newtons? So the work of the force P.
I'm divided in 12 using the 345 triangle.
That's one way. Now let's think about the fundamental definition of work. what is the work? Remember the fundamental equation of work?
Yeah.
Yeah, it is force times distance. Agree?
Yeah.
All right. Now the force times distance, the work done is the force multiplied by the distance on the same path. So for me, if I know that the cable unraveled 2 meters for along the 400 Newton applicable force, then this is going to be 400 times 2. I don't have to find 345.
Yeah.
Right? So this is 800 joules. You understand this one? Why I did not find its component on the X or the Y?
Yeah, because it tells you the 2 meters.
Yes, it tells you that it went 2 meters.
Yeah. So you just
If you find this the components of 400 Newton on the X and the Y, then you would need to see the 2 meters components on the X and the Y, and then multiply the component Fx by the component of 2 meters on the X and the component of 400 on the Y and the component Y. And then you add them up, they are going to be 800 joules.
you have to do all the ratios and stuff.
Exactly.
It'd be
So now I've got T2 is this value, T1 is 0, sum of work is 800 joules. I sub in the values, I will find omega 2.
Okay.
Now,
Not too bad.
not too bad. We will have a close look at the solution. Before we move on, can we solve this question using conservation of energy? So keep in mind, conservation of energy requires always conservative forces. Now the fact that I have an external force indicates to me that these forces are not conservative. So this type of question, I cannot use conservation of energy to solve for it. We will discuss this a little more in the coming questions. Let's have a look at this bit here, which is the solution. So you can see my free body diagram, my kinetic diagram. T1 is 0, T2 is this value. I found some of work, place everything, I find omega 2. This node problem cannot be solved using conservation of energy, because P does some work, it's not a conservative force.